Hey everyone, welcome to episode or part 2 of the CSWE practice series. In this video, we're going to be looking at the weldments, sheet metal, cut with surface, and surface modifications, which is basically everything that I missed in the last part. We're not going to be looking at bills of material as I find it quite easy to do. I don't think any practice would be useful in that regard. I think it's probably one of the easiest parts of the exam that they want you to cover. If you have or do find you have issues with that, let me know, and I can make a practice video just for that. So first, let's make a part here and take a look at the first thing we have to create. Let it load, and like always, these practice videos are live. So we have a weldment here we have to create. Seems to have a bottom kind of section, a top section, and then connections between the two. The bottom is bigger. It's section B cut out right here. And we can actually see it's drawn all for us with all the dimensions. So we can do that really quickly right here. Let's make it here. Doesn't matter the dimensions yet, we'll dimension it all. And let's take a look at all the dimensions. 100, 70, 30, 40, 25. Now, you want to try to kind of get all those in your head if you can. Accuracy beats speed, but if you can have both, that's ideal, especially when the exam is timed. I find you have enough time usually to check your answers, but the more time the better, right? Those are collinear. Oops, I just exited the sketch because, of course, they're collinear, so they have to be defined. 25, and there we go. Bottom sketch is complete. And okay, between the bottom and the top, of course, the center lines for the weldment, we have 80 millimeters. So we'll create a plane that's 80 millimeters from the front plane. Reference plane, 80 millimeter offset. Create this one. Now we're going to make a sketch on here. Normal to plane, Control 8, great tool. Or a tip to have. Control 8 makes it normal to whatever you're selected. So it seems to be that there's a 5 millimeter offset between the outside and the inside everywhere, and then instead of kind of following that rectangular thing, there's two segments that are sticking out kind of like a triangle at 135 degrees. So what we can do is offset this, reverse it, 5 millimeters. Okay. Now, these guys are branching off at 135 degrees, so we can delete these with the trim, create the two lines, and then dimension it 135 degrees. Sorry if my computer is a bit loud. I'm trying to get a new one, so you don't have to hear that when I'm recording. That's the main reason I actually try not to do live videos. But for these, it's just easier to kind of hear me think, because I can't script the thinking. So next we want to create these guys, these segments, and we can do that with a 3D sketch. Now these guys are just straight vertice to vertice, the corresponding offset, but then these guys, it's different because, of course, the upper and lower part aren't the same. So it kind of goes up, down, up, down, up, down. So that's going to be quite easy to make, actually. Nothing too complicated there. And when it comes to making our weldment, that's quite nice because actually to create a weldment with one group, you can either have all the sketches be parallel or the sketch be continuous. And since it's up, down, up, down, up, down, kind of, if that makes sense to you, let's see where it starts. At the bottom and then the top. Okay. So basically, see how I'm just doing this with one thing, one line. I'm not changing the start and end. You can kind of make that all one group, which makes it just easier and quicker to make the weldment. So let's exit that sketch. And then, of course, next we want to make the profile. So it's a 3 millimeter outer diameter rod. Quite simple to make. We'll just create a new part. Sketch, front plane, circle, 3 millimeters. Exit that, and now, of course, to save it as a weldment, we need to click the sketch, save as, library feature part right there. And I've already created my own, what is it called? Sorry, folder system, basically, just to make it a little bit easier, because you should know how to do that by now. 3mm rod, there we go. And what I haven't done is add that folder into SolidWorks, so we can just kind of practice that again. So we want to go to the weldment, all the way at the bottom, weldment profiles. We're going to add, and this always messes me up, so if it messes you up, don't worry. We would like to do this one, select folder. Okay, that should be good. Sometimes just with the hierarchies of the folders, it's a little bit tough to figure out which is the right one, and I think we did it right. So we have the standard, then the type, and then the size. We have a 3mm rod, perfect. Got it right the first try. Hopefully I would. I am a CSWE myself. But of course, sometimes it's just a little bit of a tough one to try to figure out the right way. Sometimes you're up a folder, sometimes you're down a folder. So I'm creating the new group on the bottom, and then I'm going to create a new one on the top, like this. And then if you take a look, it looks like, just from taking a look at this, the upper and the bottom have like hierarchy in the cut list. So I can create a new one here. And now watch, I can't click that because they're not parallel, right? But I'm going to just do these quickly and then show you what I was talking about earlier with how it's continuous. Because these guys are all continuous, I can click them all in one group, right? Because they're all touching. And then that is the weldment we had to create, and it's finished. Now, next we want to take a look at, will it let me, there we go. So next we're going to have to open this assembly. Now if you can't open SolidWorks assemblies in this year, what you can do is download these as the STEP step files and basically just do the same thing. We're going to do a cut with surface your own way. You're going to have to figure out how to do this yourself with the centroids of the part, so basically like the very central parts. So if you were to think about this at the origin of each part being coincident, basically it should make sense to you how to or how to think about how these guys would intersect. Maybe doing that with a step file might be harder, but luckily in this scenario we already have, oops, not recent, we already have the assembly. So we can go to our CSWE practice assembly, open it up, here we go. So we have two parts, and we want to create, basically, cut this guy using this surface. And if you take a look, we can't actually use the combined common because of the internal geometry of this part. It's missing, so it would actually not create the desired part we're looking for. So one way we can do this, how I would do this on the CSWE exam to make it quite simple, is we have assembly file. We can actually just save this as a part file, so that we have the geometry we need from the assembly. It's already figured out for us, right, the location, but we want to have the ability to edit the parts, or edit the assembly as if it was a part. So I saved it as a part file, and we can see that it's a part file over here. The assembly is now a part file, and you'll see what I mean by that. Proceed with feature recognition, no. This surface shouldn't be here. This was from when I was practicing to make sure if it would work, so in your scenario it wouldn't be there, but I'm going to show you how to make it anyways. So basically we want to create the surface of this guy, turn it from a solid to a surface, the outside. We can hide this body right here first, so it's easier for us to do. And of course, if you remember, the best way to just convert a surface is to use the offset surface with a 0mm offset, and we can just click all of our surfaces. Since there are not many surfaces here, oops, I find it just easier to spend the extra 10 seconds to make sure I get them all instead of using a special selection command, like a tangency or something, just because sometimes those select more or less than you need it, and you don't know until it's too late. So now we have this surface. We can actually hide this body. We don't need it anymore. We have the surface we need. We can show this guy, and quite simply, we can use cut with surface, select the surface. It's pointed inside. We want to cut the outside. We flip it, and we can just select this body, and then there you go. We can hide our surface body and see, oops, we have the part we were looking for. And that is exactly what you need. Okay, so next we're going to look at, I believe, yes, the chair. Okay, so what we're going to do is there's this little surface on the top of the chair, and we're going to want to offset it 10 degrees this way and 10 degrees this way, because we can do that as it's on a circle, and then get rid of the original one. Okay, so the file is given to you in, I believe, a step file or an IGES, I'm not sure, doesn't really matter, it's an imported surface. Sorry, I just had a phone call. So basically what we want to do here is delete this surface, and then use the move body to move this guy 10 degrees this way, 10 degrees that way, and then patch up the surface by recreating it, and then delete the intersecting surface, which should be like below here, because we're going to revolve this guy back. Now the first issue, is that if we try to delete this guy right here, we're going to run into some issues when we recreate it, because down here there's a fillet and there's no flat surface to convert the entities from. So to solve this, what we can do is enable our temporary axes about which we want to rotate this guy, go to our features, and create a reference plane just creating it this way. That's a very small plane. So that we can basically cut this guy using some sort of trim, or probably some sort of, I'm going to use a split line to split this guy. So we only cut the upper part of the surface, which means that we can basically use the flat plane to convert the entities when we cut it, and then revolve it all the way around. This will make a lot more sense when I do it. Explaining stuff like that is a little bit tough to do. It's not exactly my strong suit. We're going to make another plane here, 45 degrees, like so. And then use the split. Oops. Select the plane. There we go. As you can see, it's split there. We'll do it the same thing on the other side. There we go. And now we can delete this face, or these four faces. Perfect. Now, next, what we're going to want to do is revolve this guy, or I guess make a copy of him. Copy, 1, perfect. I guess that setting was there from before. Select that axis of rotation, select this body to copy, 10 degrees. Do that, do the same thing again. Come on, there we go. Negative 10 degrees. And select this guy. There we go. Delete the middle body. And now the geometry is created. And now what I was talking about before, we can sketch on this guy, convert these guys right here, these edges, and we couldn't do that over here because again it's curved. It would be a lot harder to do. One more thing to note, I'm not going to knit this surface together because it's broken over here. I'm going to leave that for you to do if you want. what you would do is basically create a plane between these two, a midplane, revolve these two surfaces, or sorry, mirror them to this side, and then you'd be able to knit it once we're done. But I'm not going to do that just because it's a bit tedious. That's my bad for not properly exporting the surface, but I guess it just gives you a little bit more practice, so definitely intentional. I'm kidding. There we go. And now it's complete, except for the fact that if we were to look at this with a cutout, there we go. This right here is the issue, the surface below it. So we want to get rid of that. Now, in my previous video on the surfaces, what you would do is use the trim surface, but because this is a bit more complex with all these different mating surfaces, you actually can't really do that. So, what you can do, however, is use, this is going to be a little bit of a longer way to do this, but it's the only way that I really know how to do in a quick amount of time at least. Use the composite curve to create this curve right here. Then what you're going to want to do next is go to sketch, create a 3D sketch. What we're going to want to do is then convert that composite curve we had. It was already selected, that's why it worked like that. Then we're going to want to go to surfaces, create an extruded surface. We're going to go mid-plane. And since, you're going to see what I mean in 1 second, but we can choose this way to go up and down. It doesn't have to be up and down this way, it can be up and down this way, because we're going to use this surface to basically trim this surface. Can hide this guy just to make it a little bit easier for us. Where is it? This guy right here. And while we're at it, we'll hide the other guy. Where are you? Here. And I guess while we're at it, let's just do two at once. We'll create a midplane here. We will mirror our surface. About this plane. I have no idea why that's not working. So, let's try that one more time. Maybe it's just I'm being stupid. But if not, we can always just bodies. I'm just not smart. I was trying to use faces when I should have been using bodies. Age-old mistake. Anyways, so since the composite curve was already going through where it's going to intersect, it doesn't matter if it's going this way, if it's going this way, in terms of the surface. All that matters is the intersection, and since the composite curve, like I said, was the intersection already, it doesn't matter. So then we can go to surfaces, use the trim surface. Now we can use the trim surface tool because it's a lot simpler geometry and it's going through, so SolidWorks likes it a lot more. I guess that's the best way you can explain it. Do this on both sides. There we go. And we don't really need direct editing. We don't need these anymore, so we can delete them. And we can show these guys again. And then there we go. We'd be able to knit this together. I'm going to leave this for you to do as your own exercise. If you have troubles with it, of course, just leave a comment, email me, whatever. But I think you should have the skills to easily patch this little geometry mistake. But that's how we create two of them. Now, a good thing to remember is about using the composite curve and the 3D sketch. You can actually easily extrude the composite curve. That's why I turned it into a 3D sketch, just to make it a bit easier. And that's going to be really helpful if you're finding the trim isn't working with a complex geometry such as this one. For our last part here, we have this imported sheet metal part, which is originally in an IGES file. I just imported it, and what we're going to do next is basically convert this into a sheet metal part by using the convert to sheet metal functionality. we can select this face up here as our basically like our base face, and then it automatically fills in 4mm thickness, 0.7366mm internal bend radius, which is correct. You can verify that yourself using the measure tool. Okay, convert it to sheet metal, and we can see that this worked because we can flatten it out and see the flattened version, I guess you could say. So basically now what we need to do is add in this cut right here to this side of the sheet metal, and we can do this of course by unfolding our sheet metal. We don't have to unfold everything just because we're going to do one corner. So to make it easier on our computer, we can just simply select the one side we need to unfold, make a sketch, dimension it all out. You can go back to the drawing. It's on GrabCAD, of course. I know the dimensions by heart because it's quite simple. It's a 25mm offset from this side, 25mm thick, 100 from the very end, and you're going to want to make sure you click the right line. 100. Oops, I put 10. Then 25 from here. 25, yet again. And when we go to do the extruded cut, you're going to want to make sure to link to thickness so that when you fold it back up, the extruded cut will work. And we can use fold this face because we have unfolded that one. Click all of our bends. And there you go, that's our cut that we needed to make. And it conforms with exactly what we needed to do. So perfect, that's the second part of the CSWE practice series. I hope you enjoyed it. If you learned anything, subscribe, like the video. If you have any questions or concerns, feel free to leave a comment, and I'll see you in the next video.